Hello, this is Jennifer Dassinger with A Plus College Ready, and I'm here today with you going over our practice problems on Unit 5, Bonding and Molecular Geometry. This is our second part video of our practice problems 22 through 30. We are going over our free-released former AP multiple choice questions. Please feel free at any time to stop the video and to draw the Lewis structures and review the content in your notes. Let's begin. Number 22 is asking which molecule has a central atom exhibits an sp3d2 hybrid orbital? Well, think about it like this. Remember your VSEPR structures. Remember those molecular geometry shapes. And if you look at the hybridization of sp3d2, you see that there's one S, 3 Ps, and D2s. Therefore, there has to be a minimum of 6 bonded atoms. And this could be bonded pairs and unbonded pairs around the central atom. And when you see that, you think of your structural shape of B, an octahedron. And that would be exhibiting an AX6 structure. All right, number 23. Which of the following molecules has a dipole moment of 0? You're going to have to draw the Lewis structures. And if you notice, B, C, and D all have unshared pairs of electrons around the central atom, or a polar end. When you look at A, benzene, it creates a hexagonal shape, a delocalized model. And its bond order, remember, is going to be a 1.5. So because it has that resonant structure of the alternating double and single bonds, and there's no polar end, it is a 0 dipole moment. 24. Which of the following molecules has the largest dipole moment? Well, if you look at the largest dipole moment, you're going to be looking at who has the greatest polarity. So if you look at hydrofluoric acid, remember, fluorine is very polar, and it has a very electron-rich end versus hydrogen has a very electron-poor end. It only has 1 electron to share, and fluorine has 3 sets of unshared pairs of electrons. All right, moving on. 25. Which of the following has a 0 dipole moment? Again, draw the Lewis structure. Sound like a broken record. And when you draw those Lewis structures, you're going to see that letter C, phosphorus pentafluoride, creates this trigonal bipyramidal shape. It has no unshared pairs around the central atom. Therefore, it has AX5 as its VSEPR shape. Okay, 26. For which of the following molecules are resonance structures necessary to describe bonding satisfactorily? Again, the definition of resonance means 2 or more Lewis structures. So not one structure can accurately depict the molecule. And the only one that fits this is going to be B, sulfur dioxide. Refer to the notes for more examples of the resonance structure. 27. The structural isomers that we've seen previously in our question series, in number 5 to be exact, again, here they are, ethyl alcohol and our ether, would be expected to have the same values for which of the following? Now we assume ideal gas behavior, so we have to assume that. And if they're structural isomers and they have the same shapes, they're going to exhibit different properties, but they're going to have same densities. So that's huge. So 27 is A. They would have the same gas density at the same temperature and pressure because they have the same number of molecules in the same ratios. All right. Number 28. Which of the following, let me scroll down and move in. Okay, here we go. So which of the following of the bonds arranged in order of decreasing polarity. And actually, yes. So we're looking for decreasing. Sorry, I was looking at 28 and 29. So looking at decreasing polarity, we're looking at who is the strongest to the least polar. Well, as in previous questions, you know that you're going to be looking at who's the strongest first. And we know that something that has fluorine, because it has the highest electronegativity, is going to be the strongest. Then if you notice, A has hydrofluoric acid. That would be the most polar. The nitrogen to fluorine would decrease, and it would have a electronegativity of 3, actually. And then if you're looking at the electronegativity between fluorine and fluorine, we're going to have a value of 0. So you go from 4, 3 to 0. And so in 28, A is the best answer. All right, now if you're looking at number 29, it's a very similar question, but in a backwards way. There's only so many ways they can ask these questions. So I like to give them in both sets in different formats so kids can be able to see that. On the basis of the information above, which of the following arrangements of binary compounds in order of now increasing bond polarity? So now obviously we're looking for something that has fluorine on the end, okay, the end of it. So in this case, yes, A is our best answer. We have methane. So if you took the difference between carbon and hydrogen, you're going to have electronegativity difference of 0.4. If you took the electronegativity difference of silicone and chlorine, its electronegativity difference is going to be 1.2. And then finally, when you take the electronegativity difference between sulfur and fluorine, you will have a value of 1.5. So practice with the other sets and notice the numbers. Last question of our multiple choice practice problem set. On the basis of molecular structure and bond polarity, which of the following compounds is most likely to have the greatest solubility in water? Well, as we know, water is polar, and it's polar because of our oxygen has 2 unshared pairs of electrons on the central atom. So I sound like a broken record, but go back and draw those Lewis structures. So when you draw the Lewis structures, you're going to see that methane in A and carbon tetrachloride in B have no unshared pairs of atoms, unshared pairs of electrons, around the central atom. So they're both nonpolar. We look at D and B, C and D. When we look at C and D, we look at ammonia, NH3. And ammonia, we know, has an unshared pair. When you draw phosphorus pentahydride, when you draw that, you're not going to have an unshared pair, and it is also going to be nonpolar. So remember the phrase, like dissolves like. So C is our answer, because as we know, ammonia is definitely dissolved in water and used in a lot of cleaning agents. So I hope these practice problems have been helpful in reviewing the basic content of bonding and VSEPR. Thank you, keep practicing, and stay tuned for our next video series.